Good morning, I'm Marukiraj signing in for chapter 4 heat. This is the second part of the class, second part of the lesson. Last period we learned what is heat, the definition of heat. We learned what is temperature, the instrument used to measure temperature, that is thermometer. And we learned that there are three scales like Celsius scale, Fahrenheit scale and the Kelvin scale. We also learned about the two types of thermometers based on the liquid use, that is mercury thermometer and alcohol thermometer. And we learned the advantages of using mercury in a thermometer than alcohol. Now let us enter into today's portion, and today we are going to learn about the different types of thermometers. Last class we learned the different two types of thermometers based on the liquid that is used, and today we are going to learn the different types of thermometers based on its usage or function or even I would say based on its characteristics. And later on we are going to learn about the transfer of heat. So we have learned about transfer of heat in lower classes, especially in 6th standard. We are going to learn about the transfer of heat to get an updated knowledge about it. Okay. Yes. Now let us enter into the main core of this part 2. Basically, as I said, as I was saying just now, there are different types of thermometers. Some have been given in our book, like clinical thermometer, minimum and maximum thermometer, laboratory thermometer and digital thermometer. So clinical thermometer, as you all know, which is used only to measure the body temperature of humans or animals. That is the significance of clinical thermometer, which cannot be used to measure other objects. Again I repeat, clinical thermometer, as it is in the name, clinical, which is used to diagnose the clinical symptoms of a person or an animal. If I want to check the temperature of a body or temperature of other objects except humans and animals, any object, if I want to check the temperature of that particular object, or if I want to check the temperature of a place, maybe a room, any room, maybe your house or maybe school or somewhere else, or even outdoors, in that case I have to go for a laboratory thermometer. I should not go for a clinical thermometer. Let me explain why I should not go for a clinical thermometer later. Okay. Then third, we have this weather forecast, which is done by this so-called minimum and maximum thermometer. So in news, when you check a news, or when you check a newspaper, you will find a weather forecast sometimes. Yes, so in that case you come across minimum and maximum temperature, which is done based on this the third type of thermometer called as minimum and maximum thermometer, which is mainly used to check the forecast. Okay, based on which we indicate the forecast or weather of a particular place. Then at last, an updated form of clinical thermometer is none other than the digital thermometer. So where we don't use any liquid at all. So before maybe last period we learned that clinical thermometer or laboratory thermometer or minimum maximum thermometer, in all the thermometers we use either alcohol or mercury. But in digital thermometer, fully electronical devices will be present inside and no mercury is used. Our first importance goes to clinical thermometer, which is otherwise called as doctor's thermometer, because doctors use this thermometer to refer or to identify the temperature of a person or an animal. If the doctor is a veterinary doctor, he uses a different kind of clinical thermometer, which will be slightly bigger than the normal clinical thermometer, based on which he identifies the temperature of a particular animal. Veterinary doctor identifies in animals. So before studying about this thermometer, this thermometers, especially in humans, let us see about humans, it can be kept, it should be placed in a particular organ or particular site of a human being. So it can be placed below the tongue, option A, or it can be placed in the armpit. I hope you know what is in the armpit, okay? If you second option. And the third option, it can be placed in the anus. So in these three ways, a doctor can identify the temperature of a human being. So in case of children, either the doctor can go for armpit or in anus. Mostly anus is not preferable. So especially in case of females, the thermometer is placed in the elbow. So if you fold your forearm, so you get that site is actually called as elbow. So in females, instead of keeping inside the mouth, the thermometer can be placed in the elbow. Okay, so these are the places where a doctor prefers or identifies the temperature of a person. But in case of animals, the best site of identifying the temperature of animal is none other than anus. Okay, fine. So now let us learn about this thermometer, clinical thermometer, which is always called as doctor's thermometer. So it comprises of a long tubular structure. On one end of the tubular structure, you come across a small bulb which consists of mercury. The continuation of this mercury will be found inside the thermometer, inside the tube, in the form of a long, narrow, uniform glass tube. So you can find at the center a long, narrow, uniform, so which has a background of yellowish in color. So that is actually the long, narrow, uniform glass tube, which is the continuation of the bulb. So the mercury from the bulb, so what you find on the left side is the bulb. From that bulb, the mercury runs into the long, narrow, uniform glass tube, and nearer to the bulb, so actually inside the narrow tube, nearer to the bulb, you come across a small kink. So what is kink? A small deviation which is found near the bulb internally is actually called as kink. So this is found only in clinical thermometers and is absent in laboratory and other forms of thermometers. The range of a clinical thermometer is about 35 to 45 degree Celsius, 35 to 42 degrees Celsius. In earlier days, we were in India, we were following Fahrenheit temperature. So in those thermometers, the range will be from 94 to 108 degree Fahrenheit. So this is a earlier way of or earlier thermometers, which consists of Fahrenheit scale. But I would say in nowadays we have both Celsius as well as Fahrenheit. So if it is Celsius, it is from 35 to 42, not 45, 42. And if it is Fahrenheit, it is 94 to 108 degree Fahrenheit. And the normal body temperature of human beings is, in Celsius, it is 37 degrees Celsius. If it is Fahrenheit, it is 98.6 degree Fahrenheit. If it is Kelvin, it is 310 Kelvin. So it may varies to some person to other. So this is an average normal body temperature. So 37, which means it may be from 35 to 37, 98.5 or 98.6 degree Fahrenheit, and 310 Kelvin. And one more thing you have to note, which I have not mentioned the last class, that is in Celsius and Fahrenheit you come across degree Celsius and degree Fahrenheit, which is not expressed in case of Kelvin. So in Kelvin you have to write 310 Kelvin without mentioning the degree. Now certain measures that has to be taken, certain precautions that has to be taken while reading a clinical thermometer. Let us see one by one. First of all, the thermometer should be washed in an antiseptic solution like a Dettol. Okay, Dettol mixed with water. In that the thermometer should be washed before and after use. Secondly, we are not supposed to hold the bulb of the thermometer when used, because when you hold the bulb, I mean the person who is checking, especially doctor or a technician who is checking the patient's temperature, if he holds the bulb, automatically the thermometer shows the wrong temperature of the patient as well as the person who is handling. So we are not supposed to hold the bulb of the thermometer. I hope you know what is meant by bulb. Then third, we must make sure that the temperature, that the mercury is below 35 degrees Celsius. So for this we can go for jerking the thermometer before use, such that when we jerk, automatically the mercury, if it is above 35 degrees Celsius, it runs towards the bulb. Then 4, we should handle the thermometer with great care. Maybe last class I said mercury is a harmful heavy metal, it's a slow poison, and I said various effects of this mercury. So when you are handling the thermometer, see to that you don't hit any objects, so that the thermometer does not hit any object and break, such that the mercury will be exposed, and thereby that results various problems. So great care should be taken when you use the thermometer or handle the thermometer. Then 5, when you are reading the temperature of the thermometer, you have to keep the level of mercury along the line of sight. If you are based on that, you have to tilt the thermometer such that the mercury is visible to your eyes. If it is not properly placed, if the thermometer is not properly placed, it will result in a wrong reading of the temperature of the patients. Now let us see how a thermometer must be used. So usually the thermometers will be inside a cap. So if you look, you will come across the left side the bulb, and in this video you come across the readings. So in this thermometer you have both in Celsius scale and in Fahrenheit scale, and you have to hold only on the opposite side of the bulb. Okay, you are not supposed to hold the bulb at all, okay, as we discussed now. And if you look into the readings, it is in both Celsius and Fahrenheit scale. This is the bulb. So inside you come across a long narrow tube, and before use you have to wash the bulb part in a antiseptic solution. So this is the kink that I said before, a small pending which is found only in clinical thermometer. And after jerking, after washing, you can keep the thermometer inside the mouth below the tongue. Okay, and you have to wait for 1 minute. After 1 minute, the thermometer should be gently taken away from the mouth of the person. So it's not supposed to be mouth, it can be in armpit or it may be in a elbow. So this is armpit, and it can be measured even in elbow, especially in females. So after 1 minute, the thermometer should be gently taken, and as I said in the precautious measure, so it should be placed upright to the eyes such that the mercury level is visible, and then the reading is noted. If at all, if I want to measure the body temperature of all the students of a class, so based on the procedure of how I said just now to measure the temperature, so you have to take the temperature of all the students, and you have to note down the reading in a tabular column, that is name of the person his temperature, name of the second boy, his temperature, name of the third boy. Like that you can note down all the temperature of all the students, and then we have to go for a calculation of average temperature. The formula for finding the average temperature is the total temperature of all the students. So you have to add the temperature of all the students by the total number of students. Suppose if there are some 60 students in a class, so I have to add all the temperature, the temperature of all the students should be added. So one will be having 37, other will be having 34, third boy will be having 35. So all the temperature should be added. So it should be written in the numerator divided by the total number of students, that is divided by 60. That gives the average temperature of a class. Before going to the next type of thermometer, I said at the beginning, a clinical thermometer cannot be used to measure the temperature of other objects. Why? That is, there are two reasons why a clinical thermometer cannot be used. One, first of all, a clinical thermometer consists of a kink, which is not found in laboratory thermometers. So if I am using a laboratory thermometer to measure a room temperature or to measure a temperature of an object, automatically after using I can remove the thermometer, sterilize the end and keep it aside, or I can go immediately for the measurement of temperature of another object or another room. But it is not so in clinical thermometer. For every time when I use this clinical thermometer, since we have a kink in near the bulb, I have to jerk that thermometer, then only the mercury in that thermometer comes to the bulb. Again I have to start the next reading. So this is one reason why we can't use the clinical thermometer for other purposes. Secondly, which is more important than the first point, that is, if I am measuring the temperature of boiling water, if I keep or insert a clinical thermometer in that water, a boiling water will be 100 degrees Celsius, but the reading found in the clinical thermometer is just 35 to or 32 to 42 degrees Celsius. So in that case, what will happen? The thermometer start to burst because of very high temperature, and this is the main important reason why a clinical thermometer must be used only to check the temperature of humans or animals, not to check the temperature of room or other objects. I said 100 degrees Celsius. In some cases, if it is a boiling oil, the boiling point of oil will be more than that of a boiling point of water. So all are risky. That's why we are not supposed to use a clinical thermometer for other cases. Okay. Now we'll go to the next type of thermometer, that is laboratory thermometer. In laboratory thermometer, so the same the structure is same. So you have a bulb, you have a long narrow glass tube, but here we come across the thick walled capillary tube, which is inside the or nearer to the bulb or the continuation of the bulb, ranges from -10 to 110 degrees Celsius. So this is based on the room temperature or based on the temperature that we are going to measure, that is the object's temperature that we are going to measure. So it may be very chill or very hot. So hence we have the range from -10 to 110 degrees Celsius, which is more strange compared to that of clinical thermometer. So as you all know, clinical thermometer is just 35 to 42 degrees Celsius or 94 to 108 degree Fahrenheit, but it is not so in laboratory thermometer. In Celsius it is -10 to 110. So when we are about to use a laboratory thermometer, one important thing that you have to keep in mind, first thing, you are not supposed to hold the bulb. Any thermometer, if you are handling, you are not supposed to hold the bulb. Second thing, as you look into this colorful photo in the middle, when you are checking the temperature of a liquid, the bulb of the thermometer should not touch the bottom or the side of the beaker or any container. So the container that contains a liquid, you are going to check the temperature of that liquid. In that case, see to that the bulb does not touch the container at all. If you have a laboratory thermometer, or maybe in future if you come to school, we can do this activity, that is to measure the temperature of a tap water, or you can boil a water and that also can be measured. For this you have to fix a thermometer in a stand and insert the thermometer into a container containing water. It may be tap water or boiling water or any other liquid. And again, as I said just now, see to that the bulb does not touch us, as it is in the diagram on the right hand side. And after a minute, remove the thermometer from the water from the stand, and then you can check the temperature and you can note down the temperature of that liquid. You can also do another activity to prove that clinical thermometers is unfit to find the temperature of objects or liquids or room. Okay, that is, as we discussed now, you just fix a thermometer, insert into a water, and then as usual you can find the temperature. If you are inserting this clinical thermometer, every time when you, after measuring the temperature, you have to go for a jerk. If you don't jerk the thermometer, automatically that will result in wrong temperature. So I said before, actually I am just repeating, but I have said this before, that is why we are not supposed to go for or we are not supposed to use a clinical thermometer to measure the temperature of objects or a temperature of a room. Okay. So these two activities, among these two activities, second activity you don't need to do, because if you are measuring the temperature of water, a hot water, if you are using clinical thermometer, as I said before, it will start to burst, so it is dangerous for you. So do not try this at home. But first activity which I said, to measure the temperature of a liquid using a laboratory thermometer, that is okay with a guide. Okay, so there should be some elder. If there is any elder nearer by you, maybe time being your parent or someone, in future maybe your science teacher, so with the guidance of them you can do with the laboratory thermometer and measure the temperature. Also, if you have a clinical thermometer at present, you can find the temperature of that person after 1 minute. As I said, you can use you can keep the thermometer below the tongue, inside the mouth, or in the armpit, and thirdly in elbows. Elbows is mainly for females, not for males. Okay. So try not to handle personally. Let there be some elder with you so that it is safe for everyone. Our next third type of thermometer is minimum and maximum thermometer. So as I said before, which is used mainly for weather report, to calculate the weather report. So you come across left hand side minimum and the right hand side maximum. The temperature of this the stem of this thermometer, or the tube of the thermometer, has a graduate or a reading or a scale in a different manner. That is, it is from it is from minus 28 degree Fahrenheit to 121 degree Fahrenheit, or in Celsius minus 34 degrees Celsius to 50 degrees Celsius. So as actually in this picture you come across 30 to 50, that is minus 30 to 50, but in some minimum maximum thermometer where you come across minus 34 to 50 degrees Celsius. Similarly Fahrenheit, it would be actually in this picture I have a 20 to 120, not 120, we have exactly 121. Okay, so Actually, it starts with 10 to 121 I have in the picture. But as per the book, it is given the thermometer will have minus 28 degree Fahrenheit to 121 degree Fahrenheit. And you come across one more thing in the picture, that is it will be upside down. That is the minimum temperature will be left hand side, and maximum temperature will be on the right hand side. The minimum scale on the left, it is read downwards, whereas the maximum scale on the right hand side will be read upwards. I hope you understand. So that is in the, I think it is called as ascending order. Okay, the smallest number towards largest number. So in that way, the minimum scale is read from read downwards, whereas the maximum scale is read upwards. Based on that, the weather forecast is made, and this thermometer can be used both in indoors as well as outwards. Okay, I hope you all are very well aware of this fourth type of thermometer, that is digital thermometer. So since we are in this corona period, COVID-19, or this so-called lockdown period, time being, wherever we go, we come across this digital thermometers that is used, so which is an updated form of the thermometer that I showed in the beginning. In the introduction, I showed all the different types of thermometer. That is an outdated or old form of the old model, and time being we are all using this thermometer. The difference is that in that old model, like other thermometers, it should be kept inside the tongue or armpit, but it is not so in this digital thermometer, where you come across a infrared lens in the front. When you press the measurement trigger, automatically the infrared lens will start to measure the temperature, and based on that, on the back side you come across a display where the temperature is displayed, and you can note the temperature of a person without touching him. That is the specialty of this digital thermometer. The first part of the lesson fully deals with temperature and thermometers. The second part of the lesson deals with the transfer of heat. So we are entering into the second part of the lesson, where we are going to learn about the transfer of heat. Basically, when a body is heated, the temperature rises, the temperature of the body rises, the size of the body increases, that it expands. These are the two characteristics of transfer of heat. That is, again I repeat, when a body is heated, the temperature rises, and that results in the expansion of the body. That is, the size of the body increases. Similarly, when the body is cooled, when the same body after heating, if it is cooled or brought to the normal temperature, the reciprocal of these two characteristics takes place. That is, when the body is cooled, the temperature slowly decreases, and automatically that expanded body comes back, or it reduces to its normal size. So this is an important aspect under the transfer of heat, or this is an important aspect which occurs during heating of an object. Next, let us learn about the modes of transfer of heat. Before that, just recall what we learned in the beginning of this lesson. That is, we learned that heat is a form of energy which always flows from higher to lower temperature. Always heat is from higher to lower temperature, and not vice versa. That is, the temperature will not transfer, there is no transfer of a temperature from lower towards higher. Always the heat is transferred from higher towards lower, and not vice versa. Keeping this in mind, let us start with the modes of transfer of heat. So based on the method by which the heat is transferred from one object to other, we are going to study three modes of transfer of heat. With that, almost the lesson comes to an end. But I don't worry, I'm not going to finish the lesson today. So time being, let us start with the three modes of transfer of heat. So I'm going to discuss only the first type, that is conduction. Maybe next class we'll go to convection and radiation. Okay. First, conduction. So in simple way, I can explain this three modes of transfer of heat as: if the heat transfer takes place in solids, it is called as conduction. If the heat transfer takes place in fluids, in science, fluids means liquids and gas. So if there is a transfer of heat in solid, it is by conduction. If there is a transfer of heat in fluids, that is in liquid and gas, it is by convection. And at last, if there is no medium at all, so there are three types of medium: solid, liquid and gas. If there is no medium at all, which we call it as vacuum, in that if transfer of heat takes place, then it is called as radiation. That is, when mother gets angry on you and she is getting ready with that ladle, she puts in the hot stove so that she wants to touch that hot ladle on your skin. I hope you understand. When she is angry and getting ready to put that ladle on your skin, in that case, or the second case where she is cooking, mother is cooking, and ladle, that is the large spoon called as ladle, which is in that container, after some time you will feel the other end of the ladle will be hot. This is none other than conduction, that is transfer of heat in solids. When one end of a solid is put in a fire, you can feel the hotness on the other end of that solid. I hope you understand. And that is none other than conduction. Secondly, if there is, if for example you are just boiling water or curry, some curry, okay, or rasam or any other liquid forms, in some cases, in that case, you will find the whole fluid becoming hot, and that is by convection. Not only that, when you are when mother cooks something, if you put your hand above the container or nearer to the fluid, that is curry or rasam, whatever, I hope you know what is meant by curry. Okay, don't misunderstand the word curry. Okay. So if your hand is above the food substance, hot food substance, you will feel a warmness, and that is also because of convection. And at last, the solar radiation. It is called as radiation because sun is found in a vacuum. Sun ball is found in a site where you don't have air at all. In that case, that passage of heat and light is called as radiation, and that's why we call it as solar radiation. I hope now you will understand the three modes of transfer. I am not telling the definition. We'll study the definition then and there. So time being, I just want to make you understand and be clear what is meant by conduction, convection and radiation. If the transfer of heat takes place in a solid, it is called as conduction. If the transfer of heat takes place in water or air, it is called as convection. And the transfer of heat in vacuum, that is empty space, where there is no medium at all, then that type of transfer of heat is called as radiation. There is an activity in our book which to explain the different rate of conduction of heat in different materials. For this we can go for copper strip and aluminum strip. to which you have to apply wax on one side of the copper strip or aluminum strip, and on this wax we have to place the metal balls, and now we have to place the copper strip followed by aluminum strip upside down such that the balls are at the bottom position. Fix it to a stand on one side, and on the other side we just place a burner. When the heat is transferred through these strips, the wax starts to melt, and slowly one by one the metal balls start to fall. When you compare the rate of the ball falling from the strip, it is so faster in a copper strip compared to aluminum strip, and this shows one, copper strip gets transfer of heat faster than aluminum strip. That is, the heat transfer is faster in copper strip compared to aluminum strip. And secondly, this transfer of heat, the rate of transfer of heat is not the same in all the metals. It depends on metals. It changes for each and every metal. This is what you learn from this small activity. Now let us learn the definition of conduction. What is conduction? Before I didn't explain or I didn't give any definition. I just gave you an idea, but now let us learn the definition of conduction. Conduction is the process of transmission of heat energy. So I would like to note that conduction, convection, radiation, all these three types are none other than the process of transmission of heat energy. But here the conduction is the process of transmission of heat energy in solids. I said this before. In solids, without the actual movement of particles from their position. So one thing you have to keep in mind, you have learned in 6th standard that solids, liquid, gases, there are three states of matter. In solids, you come across the particles are closely packed. Secondly, in liquids, the particles are loosely packed, and in gas the particles are far away from each other. So this you have to keep in mind. And so here, since in solids the particles are so close together, I mean very close to each other, you don't have space at all. There is no intermolecular space, one thing, and because of that only, two things I just want to say here. One, you cannot compress a solid. It is very difficult to compress a solid. Any solid you take, your cell phone or your book or your table, so you cannot compress it, and that is because of the compactly placed particles inside it. I mean compactly placed molecules or compactly placed matter inside it. But it is not so in liquid. In liquid, where you have a definite volume but no definite shape. I hope you remember, you have learned in lower classes. And that is because of the loosely packed molecules. Because of that, the molecules can occupy any shape of the jar. For example, if you are taking water or juice, for example 1 liter of water or juice, if you transfer into different jars, that liquid occupies the space of the jar. It takes the shape of the jar, but the volume will not change. But it is not so in solid. Because solids have definite shape and definite volume. Liquids have a definite volume but no definite shape, and that is because of the loosely packed molecules. And in gas, there is no definite shape and no definite volume. So I can take 1 cubic meter of gas, which can be filled in 1,000 cubic meter of volume of a container or something, or a room. The same I can even fill in or compress in 0.1 or 0.001 cubic millimeter of a volume. So gas has no definite shape as well as definite volume. This is due to the very loosely packed. So there will be large distance between one molecule and another molecule. So this is the nature of solid, liquid and gas. And now coming to the point, and because of that only there is no actual movement of particles in conduction. That is in the I repeat in other way, there is no actual movement of the heat is transferred without the actual movement of particles from their position, because they cannot move, there is no space at all. So this kind of transmission of heat energy in solids without the actual movement of particles from their position is known as conduction. I hope you could understand. Then there are two conditions for which conduction should take place. One, the two objects should be in contact. Without contact there is no conduction taking place. And secondly, the temperature of both the objects should be different. One with different temperature, other with some other different temperature. In that case only you come across the transfer of heat energy, that is you come across conduction. Because when you come across this conduction from one object to other, at one particular point you will find both the objects will be at the same temperature. At that point you don't come across conduction at all. One. And secondly, that point is called as thermal equilibrium. Okay, I hope you understand the second concept. Okay, so we have learned before that the heat transfer is always from the higher towards the lower and not from lower towards higher. And when the two objects are in contact with each other, so the temperature starts to move from the hottest object towards the less hot object, and it keeps on. You come across conduction at one particular point. When both the objects are at the same temperature, there is no conduction at all, and that point is called as thermal equilibrium. Based on the objects that allows the heat or not, based on this we classify the objects into two types: conductors and insulators. Again, you have learned this in lower classes, especially in 6th standard. So there are some objects that allow heat energy to pass through them. Almost all the metals allow heat energy to pass through them, like silver, copper, aluminum and iron. All these are examples of conductors which allow heat energy to pass through them. Whereas if they don't allow heat energy to pass through them, they are called as insulators. Again I repeat, if an object allows heat energy to pass through them, they are called as conductors, or it can also be called as good conductor. If an object does not allow heat energy to pass through them, then they are called as insulators. In some book you come across bad conductors. Insulators, they are also called as bad conductors. Okay, so which includes, insulators includes plastic, wood, rubber, thermocol, leather, air and water. Okay, so this is based on heat. We are not learning based on electricity. So you also have conductors of electricity, insulators of electricity. We are not discussing about that at this particular chapter. So we are learning only about conductors of heat and insulators of heat. Okay, so with this we'll end this today's session. So we'll meet again in the next forthcoming class. As usual I repeat once again, sorry for repeating again and again. Concentrate on the concepts, concentrate on the topics, go through the full book. That only will make you a brighter future. It will make you a brighter future. If you are not learning the full book, full concept, your future will be in a question mark. So keep this in mind and study well. All the best. Thank you.